Welcome to this dynamic movement study overview video. Dynamic movement is also known as thermal growth. Thermal growth is a bit of a misnomer because it only describes machine movement due to thermal growth. Actually, a lot of what's thought to be seen as thermal growth is due to torsional movement of machine and piping strain. The two things on which we most commonly perform dynamic movement studies are boiler feed pumps and gas turbines. There are a few traditional methods that we use instead of conducting a dynamic movement study. One of these is a hot alignment check. With a hot alignment check, we'll shut the machine down, lock out and tag out the machine, put all our alignment equipment on as quickly as possible, and then take a set of readings. In the time we do this, we've lost all the torsional movement and some of the thermal growth that has occurred on the machine. This is better than doing nothing, but it's not the best way to figure out where the machine has moved. The next thing we can do is a theoretical or TLC calculation. With a TLC calculation, we take the change in temperature between the hot and the cold readings. We take the distance between the center of the machine shaft and the shim plate of the machine and the material constant. We multiply these together and will determine the theoretical thermal growth of the machine at the shaft. The third thing that we do is get a specification from the OEM. The specification that's given to us by the OEM is on their machine, in their facility, under their operating conditions, and in their environment. This is going to be different than our machine in our environment under our piping geometry at our specifications. It's better than doing nothing, but it's not the best thing we can do. The best way to determine the actual dynamic movement of your machine is to measure it. There are a few ways we're able to do this, but the best way is to perform online monitoring. The best way we do this is by hooking up a laser and a target to monitor the movement of the machine. By doing this, we're able to get the horizontal offset, horizontal angle, vertical offset, and vertical angle that happens across the coupling of the machine. We can do this at each one of the couplings of your machine. Another way to do this is to take snapshot readings in the cold and the hot state of the machine. It's not as good as taking real-time measurements, but we'll actually be measuring the dynamic movement of the machine. Thank you for watching this dynamic movement study video.